right, so let's compare these two real integrals. Okay? As we've seen before, I can use this integral in order to determine the value of this one. But why would I ever do that? What's the point of looking at this integrand as opposed to this one? Okay? Remember, it's all about how we can close the contour. We're trying to make our real integral that takes place along the real axis into a closed loop integral that'll be easy for us to compute the value of by using residues. Okay? When we close this integration contour, we're hoping that the part that we have to add to close it will go to 0 in the limit as r tends to infinity. If I close like that, I can ask about the function cosine 2z along this curve. Now, remember, cosine 2z is defined in that way. Now, we can do this in general. It'll suffice for us to just look at the behavior of this function at this point where my arc intersects the imaginary axis. It'll be at IR. When z equals I capital R, I'll get e to the 2I IR minus 2R plus e to the negative 2I IR. That's 2R. Now, as r tends to infinity, that e to the positive 2r will not be muted. It doesn't matter what power of z I have in the denominator. E to the 2r divided by every power of z will go to infinity. So that means that this semicircle at infinity will not vanish in the limit as r tends to infinity if I try to use this integrand. Okay? What if I try to close the? Well, now I'm going to look at z equals negative IR, and now this term is going to go off to positive infinity. So that means that cosine 2z is not bounded in either the upper or lower half planes. Not so for e to the 2iz. E to the 2iz only has this term. So that means that this integrand can be integrated along the semicircle in the upper half plane, and we can rest assured that that semicircle will go to 0 as r goes to infinity. In the same vein, e to the minus 2iz will be able to be closed in the lower half plane, and that one will behave itself in the lower half plane. Okay? So, in a nutshell, that's the reason why we toss that out and instead consider this integral. Here, because there's no other i's at all in the denominator, we can view this integral as the real part of this integral. Okay? Had there been an I in the denominator, like if that was 6ix plus 13, it wouldn't be as nice, but let's just say that it was. All right? Then what we would need to do is split the cosine up into an e to the 2iz piece, which we would close upstairs, and an e to the minus 2iz piece, which we would close downstairs. All right?